Okay, I guess we could look at one last example about factoring. It's about factoring by grouping when we solve. So if we had x cubed plus x squared minus 9x minus 9 equals 0, okay, there are 4 terms here, and none of them, there isn't a greatest common factor to all 4 terms. However, if I was to group them like this, looking at the first 2 terms, there is a greatest common factor of x squared, which would leave behind an x plus 1. If I would look at these 2 terms, the greatest common factor there is 9, but not just 9, there's also a negative 9. Okay, so I could pull out the minus 9, leaving behind the x plus 1. And don't forget the equals 0. So now we have 2 terms. Here's their first term. Here's the second term. And we refactor. Between these 2 terms, there's a greatest common factor of an x plus 1. So I can pull out the x plus 1, which will leave me with an x squared in the first term, and then the minus 9 in the second term. All of that's still equal to 0. So now I have 2 things multiplied together, and using the 0 product property, then either the first equals 0 or x squared minus 9 equals 0. In this case, x is equal to negative 1. And here we would get x squared is equal to 9. And then taking the square root of both sides, x would be equal to plus or minus 3. Again, if you looked at the graph of this, it looks approximately like so. And the x-intercepts are coordinated with our solution. So when x is negative 1, the function is 0. When x is negative 3, the function is 0. And when x is positive 3, the function is 0. So the x-intercepts and the solutions are very closely related. Okay. All right, let's deal with some more radical equations. Anytime you have a radical in an equation, it's called a radical equation. Okay? It's quite simple. That's all there is to it. So let's see here. Let's just dive into some radical equations. Okay. So, for example, if you had to solve the square root of 15 minus 2x is equal to x. The problem is we have x's on both sides of the equation, and some of the x's are wrapped up underneath the radical. So first we have to get rid of that. And I can do that by squaring both sides. Then the square root and the squaring will undo each other, and we'll have 15 minus 2x is equal to x squared. And now this is just a quadratic equation that we know how to solve. I could move everything over. X squared, I'll add 2 x's and subtract 15 from both sides. And now we can use any of our methods to solving. I think this one will factor x plus 5, x minus 3. Okay. And now that it's factored, I can see then either the first factor is equal to 0 or the second factor is equal to 0. So either x is equal to negative 5 or x is equal to 3. And we can check these and they would both work. Negative 5, this would become plus 10. So the square root of 15 plus 10 is 25. And one of the square roots of 25 is negative 5. It's not the principal square root, but it is, Actually, let me look at that. Let's look at that together. Okay, so let's do our check. All right. Let's do x equals 3. Okay. So if I put that back into the equation, I have the square root of 15 minus 2 times 3. And we're asking ourselves, does that equal 3? So the square root of 15 minus 6, well, that's equal to the square root of 9, and the square root of 9 is 3. Check. Now with x is equal to negative 5, I want to show you what I was talking about. Okay, so 15 minus 2 times negative 5. And we're asking, does that equal negative 5? So, working underneath the radical here, the square root of 15 plus 10, that's equal to the square root of 25. And this is 5, and 5 does not equal negative 5. So let's check our solutions. Okay. And a way I really like to do that is to do it graphically. Okay. So where is our original equation? Our original equation is the square root of 15 minus 2x is equal to x. So I'm going to put this in Desmos. Let me pull that up so we can look at this very quickly. I don't know if I put this down, if you guys can see it. Let me turn that light off. Okay, so we want to start graphing with Desmos. Okay. Our first part of the equation is the square root of 15 minus 2x. Okay, so this is that graph that just popped up. And I want to know where that's equal to the line x. Okay, so this is the line y equals x. And what I'm looking for now, when I graph the two sides of the equation, is I'm looking for the intersection points. Okay. So we can see an intersection point happening here, and that point is at 3, 3. The x value is 3. We had thought that there might be a solution at x equals negative 5, but these graphs don't intersect there, so we only have one solution. We have to throw the other one out. Okay. So 5 does not equal negative 5, so our only solution then is x is equal to 3. We're going to do some more checking on this so you can see what will happen. Okay, let's try another example. Okay, let's try the square root of x plus 3 is equal to 3x minus 1. Alright, again we have the same problem. We have x's on both sides, and x is underneath the radical. So we need to remove that radical and let's square. Now what we have to be careful is that we have to square the entire right-hand side. Now on this side, we have the square root and the squaring will undo each other, and we'll be left with x plus 3. But we have to remember over here that we have to FOIL this out. So x plus 3 is equal to 9x squared minus 3x minus 3x plus 1, or that x plus 3 is equal to 9x squared minus 6x plus 1. And now this is quadratic. So I would like to have, when you have quadratics, it's always nice to have something equal to 0. So to do that, I'm going to have to subtract x from both sides and 3. Oops, 3. So now we have 9x squared minus 7x minus 2. And we can use any of the methods that we have to solve this. I am unsure if this will factor. The leading coefficient is not 1, so I don't want to complete the square. Let's do a quick check with the AC method to see if it'll factor. So to do 9 and 2 is 18, and we need to add up to -7. The factors of 18 are 1 and 18, 2 and 9. So it will actually factor. I need a -9 and add 2. Okay. So we can rewrite this as 0 is equal to 9x squared minus 9x plus 2x minus 2. So now when I group these, I can pull out a 9 and an x from the first one, leaving an x minus 1, plus, then from here, a 2 times x minus 1. This is still equal to 0. Then again, here's our first term and here's our second term. So we can factor out this x minus 1, which is the greatest common factor between those terms. And in the first, I'm left with 9x, and in the second, with 2. And then we're just back at the zero product property. So it's either that x minus 1 equals 0, or 9x plus 2 equals 0, so x equals 1, or 9x is equal to -2, so x is equal to -2 ninths. But I would like to check these. So let's do our check. If we let x equal 1, we get the square root of 3 times minus 1. Okay, so we're checking 1. So the square root of, this is the square root of 4. Does that equal to 3 minus 1? And the square root of 4 is 2 equals 2. That checks. Okay. Now let's check x is equal to -2 ninths. So the square root, we're going to add 3. Is that equal to 3 times minus 1? Okay, so in this case, we're looking at -2 ninths. Let's think about this as 3 over 1, because I need to simplify underneath here, and I need a common denominator, which is 9. So this becomes the square root of -2 plus 27 over 9. Okay, getting the common denominator. Now here, this is like 3 over 1. And in multiplying, so 3 goes into itself once and into 9 3 times. So this is -2/3, and then I subtract 1. And I can already see there's going to be a problem here. I hope you can. The square root won't be a negative number, but let's see. So this is the square root of 25 over 9 is equal to, this is over 1, negative 2 minus 3 over 3. Okay. This is the square root of 25 over the square root of 9, using the property of radicals. And does that equal negative 5 over 3? No. This is positive 5 over 3, which does not equal negative 5/3. And so this is not a solution. But let's look at it again in decimals so you can see how that works. So in this case, I'm going to edit this. We have the square root of x plus 3. And then on the right-hand side, we had 3x minus 1. So you can see there's only one intersection point, and it's there where x equals 1. Over here would be negative 2/9, and the graph is not intersecting. Excuse me. So you have to be careful when you're doing with radical equations, because what we're doing is we're squaring equations to get to a value of x, and by squaring that, we create quadratics where we didn't have quadratics before. And when you get quadratics, then what can happen is that you'll get two solutions, and the extra solution is known as what is extraneous. You see the word extra in there. So we are creating a solution that was not actually there. So we have to double check for that. Sometimes we will have equations with two radicals, and we will have to deal with them as well. So let's say, for example, we have the square root of 2x plus 3, and we add to it the square root of x minus 2, and that's equal to 4. We still have multiple x's, and now it's not just under one radical, but it's under two. So what we're going to have to do is we're going to have to get rid of two radicals. To do this, we will eventually have to square, and we will square both sides. However, if I just square this right now, I would have to FOIL this times itself. This is going to become very messy. So in this case, with two radicals, I would isolate / separate the radicals. It will make it easier for us. So to do that, I'm going to subtract the square root of x minus 2 from both sides. So the left-hand side will now look like the square root of 2x plus 3. This goes to 0 is equal to 4 minus the square root of x minus 2. Now that the radicals are separated, let's square both sides. Now the square root and the squaring will undo each other, and we're left with 2x plus 3 on this side. But let's write this out, because we will need to FOIL this. That's what this means. Alright, let's be careful. Just copying the right-hand side. Now, the first and the first is very easy, 16. And then our outers become minus 4 times the square root of x minus 2. The inners are here and here, so again we will have the minus 4 and then the square root of x minus 2. Then our last, okay, a negative and negative will become positive, and then we have the square root. I'm just going to write this next to each other so we can see. Okay, these are our last. Now let's simplify. So we have 2x plus 3 is equal to 16. Now, these are actually like radicals. So if I have minus 4 here and I take away another 4, in total I have minus 8, and the radical comes along, square root of x minus 2. Now here what happens is that, remember, when you're multiplying radicals, you can just put them together underneath. Okay, so I have plus, and now this is the square root of x minus 2, that quantity squared, which will be helpful for us. Because, again, the square root and the squaring will undo each other, and I'll just be left with x minus 2 on this side. Alright, let's try and combine like terms and simplify this. Okay, so we have 2x plus 3, here's a 16, minus 2 is 14, then I still have this plus x, and then minus the square root, minus 8 times the square root of x minus 2. And our goal here by squaring was to get the x's out from underneath the radicals, which we did manage to accomplish to some degree. However, through the FOILing process, we still have this radical to deal with that has carried through. So now we're going to start the process again, and we will isolate the square root. Since this is a negative 8 on the outside, I'm kind of tempted to get rid of that negative and add 8 square roots of x to both sides. So we have 2x plus 3 plus 8 square roots of x minus 2 is equal to 14 plus x. This will go to 0. And now I want this square root by itself. So let's subtract off everything. So if I could subtract 2 x's from both sides, and I could subtract 3. So we'll get 8 square roots of x minus 2 is equal to 11. Let's see, 4, 2, 2, 2, 2 minus x. And now we haven't quite isolated that square root. There's still, it's being multiplied by 8. So let's divide by 8. So now our equation looks like the square root of x minus 2 is equal to 11 minus x all over 8. Now that radical is isolated, Let's square both sides. The squaring and the square root will undo each other, so we have x minus 2 is equal to 11 minus x over 8 times 11 minus x over 8. The numerator will be a little bit more work. We're going to have to FOIL. The denominator is going to be very easy. 8 and 8 is 64. Okay, let's start foiling the top. Okay. 11 and 11 are 121 minus 11x minus another 11x plus x squared. So x minus 2 is equal to x squared minus 22x plus 121, all divided by 64. And I'd like to be done with this radical, or this denominator, this rational. So let's multiply by 64, which means I need to multiply both sides by 64. And these will cancel. You get x squared minus 22x plus 121 on this side, and then on the other side we have 64x minus 128 minus 128. Okay, now it's just quadratic. We know how to solve this. So let's get it equal to 0. I'm going to have to subtract 64 and add 128. So x squared minus 86x plus 249. And I have a sneaking suspicion this cancels. Or factors. Okay. 249. 3. I know 3 goes into 249 because 2 plus 4 is 6. 6 plus 9 is 15. 15 is divisible by 3. So this is divisible by 3. So 249, 3 goes into 24 8 times, bring down the 9, 83 times. And luckily that's exactly what we need. We need to get to 86. So 3 goes into 249 83 times. So this factors into x minus 3, x minus 83. And then using the zero product property, it's either that x minus 3 equals 0 or x minus 83 equals 0. So x equals 3 or x equals 83. So these are our two possibilities. And now we would need to do our check. So let's check. Our original equation, square root of 2x plus 3 plus the square root of x minus 2 equals 4. Let's check the small one first. So we need 2 times 3 plus 3, 3, minus 2, and does that equal 4? And we're checking the number 3. Okay. So here we have the square root of 6 plus 9. It's the square root of 1. Does that equal 4? Sure, 3 plus 1 equals 4. That's a good solution. Now let's look at x equals 83. So 2 times 83 plus 3 plus 83 minus 4, or 2, does that equal 4? Alright. Okay, 2 times 83 is 6. 8 and 8 is 16. So it's the square root of 160, plus 1, 169, plus the square root of 81. Does that equal 4? The square root of 169 is 13. The square root of 81 is 9. And 13 plus 9 clearly does not equal 4. So in this case, this is an extraneous solution, and we only have one. X is equal to 3.